Vlsi lab operational amplifier. So let's start creating the schematic of the operational amplifier. So for this one, so first we are going to make use of the electric software. So java.jar electric. So if you are watching this video for the first time, so to installation of this software and some basic commands over the software, watch the first video, that is the inverter. And now just go to the file, new library or open library. So this is what we have completed till now from the previous sessions. So now we have the first we this is just a recap. So brief. Okay, so first we created the recap. First we created the inverter schematic, then inverter layout. Then after this, the NAND gate NAND gate schematic and the NAND gate layout we saw, and how to measure all those delays, timing delays and all, and common source amplifier schematic and common source amplifier layout. And this is the just the basic structure, like how to we can do without combining these diffusion. So now we are going to create the schematic of the operational amplifier. So for this one, right click on the library and create new cell, and create a schematic and operational amplifier OPAMP. So then click OK. So now we are here, and I'm just going to zoom it, Control Z. And so for the operational amplifier, so go to the components and go to the PMOS. So first we need to have the two PMOS structure. Okay, so first I will place all the components what are they required. So PMOS, and we need two NMOS here and here, and we need to have the current mirror. So for that one, we need to have one NMOS here and another NMOS here, and we need to have one current source here. So for the current source we need to go to, okay, so go to this spice and AC current. Okay, so just remember, go to the spice and go to AC current, and here place that AC current. Okay, so current source. Okay, so is there anywhere any other AC current? What is this, ampere? No. So AC current, only this. Yes, we need to have the AC current. Okay, so yeah, now and another like PMOS, we need to, another NMOS and PMOS combination we need to have here. Okay, and here we need to have the PMOS. So now I just zoom this. Okay, so okay, so I just zoom this, and now we just need to rotate this. Okay, and even make it align properly. This is like this, and this one we need to have it over here, and this is for the one voltage supply, that is in one 180 degree, and here it is 180 degree phase shift, like two phase shift voltage we need to give AC voltages. So this also. Okay, so this is PMOS, here we need to place NMOS. So okay, NMOS, and this also I'm just going to rotate this and have it over here. Okay, and after that okay, so let's connect it from here to here. Directly we can connect, and from here to here. Okay, so from here to here, and from here to here, and from here to here, and we need to connect one connection from here to here. Okay, not like this, you can just connect it over okay, just connect from here to here and from here to here, and just move this. Okay, so at the middle, and then we need to connect from this one to this one, and these two we need to have over here. Okay, so just rotate this one, Control J, and we need to have this over here. Okay, so we will just make it over here, like this. We need to connect it to the here, and connect this one to here, and connect this to here, and this one. Okay, so from here it goes to the this current source. Okay, so we'll take this little bit this side. Okay, then okay, so then connect this to, okay, keep it like this, and connect this to here, and from this plus side to okay, so from here we need to connect. Okay, and we need to connect the so here there is a one source that's here, and we just need to connect these two, and that is the input, and here another input we need to connect. Okay, then we need to connect the ground over here. Okay, then we need to connect the VDD over here. Okay, so then from this we need to get the output. So okay, so these two again we will just have it here, and here we just need to connect from here to here, and so this one is connected to again ground, this is connected to ground, and this one is connected to here. Okay, so just make like this, and connect like this, and connect like this, and from here the output is connected to this one, and this is connected to the same VDD. So we can just have these things just a little bit down, and we can connect this same thing here. Okay, and then from here we need to take the output. So go to this and add the output here. Okay, so then click on this and click this is our output. So this is the basic structure. So now we need to set the length and the width for all the NMOSes and the PMOS. So for this one, just go to this first, that is first 2 PMOS. It has the length 3.33 and width is 47.5. Okay, so then similarly for this also, length 3.33 and this is 47.5 and click enter. And similarly for this one, the length is 3.33 and width is 541. Okay, so then for this also same thing, we need to set length is 3.33 and width is 541 and okay, so then for this one we need to set 3.33 as the length and width is 5. For this also the same thing, length is 3.33 and width is 5. Okay, so after that so for this one, okay, so this is AC current. Okay, so we will just see this. AC current, I guess we need to have some DC current over somewhere, so let's check. So go to spice. Okay, so we just selected, just delete this guys. So here go to spice and we selected AC current, right? We want DC current, so just click this. Okay, DC current. Just delete these two wires for a time being. Remember, we just need to have the DC current that will going to have only one value at the center. Okay, so here DC current, then just connect these two and this value, okay, we can set means no, not edit parameters, so I guess we can set like this. So here instead of 1 milliamps we need to provide 20. Okay, so we say 20 microamps, okay, or okay, so 45 microamps, anything, so 45 microamps. Okay, so 45, right? 45 microamps. Where we can give this, I guess somewhere here we can give. So okay, so yes, here only we need to give, so just click on this. Okay, so here we need to give, just click on this 45, press the control and click on this 45. No, just bring it here. Okay, so we just need to click on this. Okay, so just to click on this, it will give 45 microamps. Just we need to type 45, and for this one we need to keep length as 84 and width as 17, and for this width as 67 and length is 7. Okay, so now we set up with all the length and the width, and we even have the current source and power and ground. Okay, all these connections. So now let's go to the tools DRC, and one error, that is okay, so where is that error? Go to errors. Okay, so here that is the extra pin, just need to, okay, so just click on this error, schematic DRC Opamp unnecessary, just delete, just press delete. Okay, just press delete, select this and just press delete. So here, where is that Opamp schematic, and now go to tools and DRC, check hierarchy. Okay, it is not deleted, so go to Opamp arc. Okay, so here, from here to here, we just need to connect. Go to tools, check hierarchy. What's error again it's giving? Okay, unnecessary pin between two arcs. What this error it is giving? Unnecessary pin between two arcs. Okay, let's delete this current source. We'll be having once again. Okay, so this also we just delete. Go to the components, go to this spice and DC current, place over here, and from, okay, so just drag this one and align these exactly to the here. Okay, then connect from here to here minus, and from here to here. Okay, so don't connect like this, extend this, and from here to here. Okay, from here to here and from here to here. Okay, so now just press Ctrl and click on this. Okay, so then here type 45 microamps, click enter. So now, okay, here we missed one connection. From here we just need to give one connection here. Okay, okay, this we need to connect. Go to tools, check hierarchy, one error found. What is this error again? Okay, so this one we just click delete this and go to tools, DRC, check hierarchy. Now there is no any errors. Okay, so now this is proper. So now we just need to create expert. So for this one, create expert v in 1. Okay, and this is the input, so just click as the input and click OK. So this is one expert, and click this one, control expert v in 2 and click OK. So these two are the input, and this is the output, control expert and v out. Then here select the output and click OK. So, and yes, since it is the here instead of ground we need to give the negative supply. It's the operational amplifier, right? So plus VDD and minus VDD we need to supply. So just go to the components, go to the pin, and here supply here. Okay, so just connect like this, and here control expert and VSS. This is VDD and this is VSS, and this is the just keep it as the input because we are supplying the negative voltage, and click OK. So VSS. So now once check the DRC, there is no any errors. Okay, there is no any error. VDD, VSS, V in 1, V in 2 and V out, and the current source, everything we have. Now we need to create the set spice model for all these things. So just select one, Control X. Okay, not Control Expert. We just need to go to the tools and simulation spice and set spice model, and just drag this over here. And for this also, for all these things, we just need to do the same thing. Select like this, go to the tools, simulation spice, set spice model, and just have it over here. Select this, tools, set spice model, select this, tools, set spice model, select this, tools, set spice model, select these, tools, spice, set spice model, and for this also tools, spice, set spice model. Okay, so now have all those things aside like this. And we need to name, so these two are this PMOS and this is PMOS, and this is PMOS, and this is NMOS. Okay, NMOS, and this is NMOS, and this is NMOS, and this is NMOS. Okay. For this one we forgot. Tools, go to spice, set spice model, and this here, and this is NMOS. Okay, so now we have PMOS, PMOS, NMOS, 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 and this NMOS and this PMOS. So now we need to write the spice code. So for that, go to the MISC and the spice code and have it over here. Okay, then just click Ctrl I, click on the multi-line text. So now we again need to do the three kinds of analysis: transient, DC and the AC. So first we need to do the DC analysis. So before that we just set this VDD and VSS. So VDD 0 DC, and what is the value? We can give 5 and minus 5, or okay, 1.8 volt we will give 1.8, and VSS 0 DC minus 1.8. so this for the VSS, and then DC current is already fixed value, it is there. Then what is any other fixed values? No, only these two values. And V in 1, V in 2 we need to give. So now for the DC analysis, okay, so now we will do the DC analysis. So V in 1, okay, so V in 1, and 0 DC 1.8, and V in 2, 0 DC and 1.8. okay, so these two, for this V in 1 and V in 2 we gave 1.8, and we do the DC analysis dot DC V in we do the DC analysis on V in 1. okay, so V in 1, and we need to do the DC analysis from minus 1.8 to 1.8 volt in the steps of 0.1. okay, so just remember 1.8 here everywhere. So this is 1.8, VSS 1.8, and for DC analysis V in 1, 0 DC 1.8, V in 2, 0 DC 1.8, and dot DC V in 1 minus 1.8 to 1.8 in the steps of 0.1. So after doing the DC analysis, we will going to get that cutoff voltage values. So after that we need to do the transient analysis. So for the transient analysis we need to give the sign, okay, for the V in 1 and V in 2. So V in 1 0, and this is the AC signal, so sign, and here we got that cutoff. After getting that cutoff we need to provide here, and 10 M and 1K. So similarly, okay, so 1K, and similarly for V in 2, okay, so V in 1 we gave like this. So similarly for V in 2, we just need to give the V in 2. So we are doing transient analysis. So if you give the V in 1 this 0 AC, then for a V in 2 we just need to give the DC, okay. So only one we need to just give the sine wave. So here DC and that cutoff, that constant we need to give here. Then for okay, so then dot tran 200 okay, 200 microsecond. After that, so AC analysis. So for the AC analysis, V in 1 same thing, 0 AC and sign off. So here cutoff and 10 M 1K, and V in 2 and 0 DC and cutoff, and dot AC in deck of 100 and from 100 to 10 G, okay. So then we need to include C5 models.txt, okay. So now we will comment all these, only keep the DC analysis, okay, then click apply and click OK. So now let's go to tools and DRC. There is no any error. So go to simulation spice, write spice deck, and now just click on the run and add trace, and here we need to have DC analysis means V in 1 V in 2, that is 1.8, have any one of this, and V out, okay, then click OK. So somewhere here we got that value. So just zoom this and click on this V out and go to this value. So what is this value? 1.0815 volt and vertical, okay. So we will take the vertical value 1.07. so that one we just need to place this. So the okay, so our note down, okay, so we need to note down the things. So I'm just creating observation, okay, which one this is? Opamp observation. So what the things we need to note down? One is the DC, from the DC analysis, cutoff voltage equal to, this is the cutoff voltage, and after that we need to do the transient analysis. In the transient analysis, V in, what is the V in, and V out, what is the V out, and gain, that's equal to V out by V in. Okay, so these things V in, we just need to measure these things now from this. So here DC analysis is done, so just comment it out, comment this out, and go to the transient analysis and uncomment this, and in the cutoff we need to have this value. Okay, so this is voltage, and here also we need to have this value. Okay, so now this is 10 m means, okay, so we just give as a okay, so 10 m, instead of that we give 5 m, so that peak to peak will be 10 m. So now let's run this circuit, and 200, okay, it's running. I guess 200 micro is too large. No, it's already learned. So instead of 200 micro, we just give as micro means it is not, we are not getting. So after the micro means we need to just give milli. So we just give 2 milli, and we just see. Okay, so we just give 5 milli, and we just run this. But this waveform we are getting like V out. We should not get like this, something sign of okay, so this is 5m, just give us a small values. Okay, 0.5, okay, 0.5m and 1k. Now just run this and add the plot plane, because that much high voltage it is not taking. So this V in and this is V out. Okay, so now we have, so here 0.5 m means 1 m peak to peak. Okay, so 1 m peak to peak. So here we can note down V in is 1 millivolt peak to peak, peak to peak. And what is the V out? V out is, we need to measure this, one cursor here and another cursor at the down, and this cursor is at the top. What is this value? Difference, vertical difference 59.773. This we just need to have it over here, millivolt. This is also peak to peak, and so V out by V in, millivolt millivolt cancel, so gain will be nearly 60. Okay, so gain is nearly 60, 59.773, that is nearly 60. Okay, so nearly we can represent that as, okay, nearly 60. Then in the AC analysis, so just copy this value and just close this, and again rerun this. Okay, tools, simulation spice, write spice deck, and just scroll it down, and here comment down this DC analysis and come to this AC analysis, uncomment it, and here in the cutoff just have this. Okay, what is that value? 1.07715, 1.07715. Then here we just need to give very small, so 0.5 m, and here 1.07715. Okay, so now just run this and add trace and V out. Okay, we can just have the V out. We will get something like this. Click on the V out. So initially it is straight till here. Okay, so till here it is straight. Then, so what is this? 35.61 minus 3, 32.61. 32.61. So 32.61. 32.61. So till that, just take this. Okay, so this is the nearest value, and we need to note down this value at minus 3 dB. Okay, so ASC analysis, so minus 3 dB, minus 3 dB at 32.58 dB, and another thing is, okay, and another thing is phase. What is the phase? 129.421 degree. And what is frequency? 1.9682 megahertz. So this is the analysis we need to do. I hope you understood this. So yes, thank you.